A lot of people, including myself, encourage people to build data science projects. And this is very good advice because it helps you to show expertise. It helps you to show that you indeed are a master of the whole data science pipeline and you can take up a project and you can deliver on it. However, I feel like something is usually missing in our advice to people, and it is how to do it. How do you take a data science project from scratch and then you build it and then you make it available to everyone around the world? In this video, I will be doing a step-by-step guide on building a data science project, what libraries to use, what you should be careful about, and what you should avoid. So let's go. The first step is loading in the data. For self-project, mostly here you are loading the data from a CSV file, an Excel sheet, or even probably from a Google sheet, wherever the data existed from. Now for this, mostly you will use the pandas library, and the pandas library has a function called the pd.read CSV. With this, you can easily load in your data. Depending on however your data looks like, you might also be using pd.read Excel if your data is an Excel file or whatever you're working with. Here you have to be careful that you have read in your data correctly. You have to make sure that column names are well spelled and they are exactly what you expect. The rows are also the exact things that you expect also on the rows. The mistake that you find a lot of people make in this area is usually that they've used the wrong delimiter. So if your file is a CSV file, that's a comma separated file, and so it means that between your columns they are separated with commas. Now sometimes the delimiter may change to maybe a colon or a semicolon, and you have to be very careful to specify this when you're using the pd.read CSV, for example. That way your file, your data is well read into the system properly. Always watch out for these because this is something you find to check if you actually reading the data properly in your take-home assignment for data science projects. In the case that you're working from a company and your data is in a database, you would most likely be writing a SQL query to connect to your database and then getting the data. And of course, depending on whatever database you're using, if you're using Snowflake or Databricks or BigQuery, you can write a simple connector from Python and then you can write your SQL query in a string and then from there get your data into your work area. So now you have your data in your work area. What is the next step? The next step is descriptive analysis. Now, in the second step, descriptive analysis, what you want to do is you really just want to understand your data. You want to know how does your data look like, or you want to know how many columns are there, what is the mean of the columns, what is the mode of the columns, what is the median of the columns. You sort of want to have a feel of the data. And this is very important. I find that a lot of technical data scientists, very good data scientists, actually spend a lot of time in this area because a good understanding of your data helps you when you move on to the next step, which we'll talk about later, when you build your machine learning model. When you understand your data properly, you can also do due diligence to knowing what is missing in your data, how do you detect missing values, and how do you replace them. For example, if you're working with a car problem, you want to know, okay, what is the most expensive car in your data set? What is the least expensive car? How many cars are blue in your data set? What is the color range of the cars in your data set? How expensive are the blue cars? How expensive are the red cars? When was the first car built in your data set? You basically really want to understand what is the story behind your data set. And sometimes you might do this by using, for example, the matplotlib library or the plotly library. I prefer that because it has a very different feel to it and it's a lot more nicer on the eyes. And if you really want to be fancy about it, you could also use Tableau or Power BI, or you could also use Looker Studio, which is my personal favorite. If you want to see how to use that, I have a video recorded. You can check that up here. Now, so here you really just want to understand how your data looks like. Now, two subsections that I would also like to just hint a little bit about under descriptive analysis is data cleaning and feature engineering. With your data cleaning is where you're trying to identify what is wrong with your data, if anything is missing, are there outliers in your data, and you're trying to deal with those. Feature engineering, you're trying to get your data ready for your machine learning model. So if you have strings, you want to convert them to numbers. I think data cleaning is a big word on its own, and if you really like me to spend time to really explain what it is all about and feature engineering and how that is well done, put a comment in the comment section and I'll be looking forward to that, and I will do a proper video to explain what that is all about. Takes me to the next step, which is machine learning modeling. So here your data is ready, it's been cleaned and it's now ready. You want to build a proper machine learning model on it. The most important library that you most likely find in this area is scikit-learn library. It has a lot of models that has already been programmed in there: linear regression, logistic regression, random forest. If you maybe want to do gradient boosted trees, you could use the XGBoost library or light GBM library or CatBoost library, depending on which one you fancy. Very important that you understand the basics of the model. What is the mathematical intuition behind it? How was it formulated? What are the assumptions of this model? This way you can easily know what model is best and for what kind of data. Now, a simple way to learn the mathematics behind some of these models is to use Brilliant. Brilliant offers the possibility to learn mathematics, data analytics in a simple and visual way. For me, the main thing that makes Brilliant is just how easy it is to use. For example, imagine you want to learn about the while loop and you're shown this very nice graphic. There is no way it's not going to stick. So if you like to try out Brilliant free for 30 days, use my link shown below or scan the QR code. You would also get 20% off an annual premium subscription. Thank you so much, Brilliant, for sponsoring this video. Now, in data modeling, the steps are pretty simple. You want to fit on the model, that is, you want to train data, you want to train your model using the trained data, and then you want to run predictions on the test data. So the process of fitting your data is where your model is basically learning the patterns in your data, the intricacies of your data, and how your data looks like basically. Now, takes me to the next step, which is ML model testing. In ML model testing, what you want to do here is to test the performance of your model. This is very important because when your model is in production, meaning when your model is available to everyone around the world to use, you don't want to have any surprises. So if you say that the accuracy of your model is indeed 80%, you want to be sure that 80% of the time it is actually correct, depending on if it's a classification problem or a regression problem. And here you want to use error checks to actually see the performance of your model on the data that it hasn't seen before. So depending on what kind of problem you're solving, if it's a regression, you would be looking at the mean absolute error, for example, or the mean squared error, or like I like to advise people to make your communication better with non-data people, maybe use the mean absolute percentage error because it's a percentage. So you are basically trying to estimate the performance of your model on unseen data. Another idea you can do is to use your train, test, validate, basically meaning you split your data into three parts. You train your model with one data type and then you test on the other. You go back to train your data again, and at the end of it all, you probably then use your validate to confirm the result of your model. Or you could also do a cross validation, which is you split your data into 4 or 5 groups, and then you train on 4 at a time, and then you test on 1 at a time. The idea behind all of these processes is basically to ensure that indeed the accuracy of your model that you've seen while you are training the model is exactly what it is when it is deployed. Takes me to the last part of the whole process, which is what everybody likes to see, the app deployment part. Now, this is the last part of the whole data science project, machine learning project workflow, that you basically now say, okay, my model is ready and I want to release it into the world. So for example, in our car problem that I shared earlier, your data is probably forecasting the prices of cars around the world, looking at their properties, their color, their make, their manufacturer, and stuff like that. Now, for personal project, I always advise people to actually deploy the app, because when you deploy your app is not just living on a Jupyter notebook, but it's now available to the world. And if you're trying to look for a job, it's available for your potential employer to play around with, to also see, and they also have an idea that, okay, you are somebody who can handle a model in production. And you can easily do this with Streamlit. I have a video here where I walk you through the process of saving your model and deploying your model on Streamlit. Check it out and I'm sure you enjoy it. If you enjoyed this video, make sure you check out the video on your screen right now where I talked about data science projects you should not do to avoid being rejected by your potential employer. Check it out and I'll see you soon. Bye.